Permutations and Combinations. But before that, I'd like to introduce myself. My name is Raghukumar Sichula, and I'm taking today this Permutations and Combinations. This is a most general topic, we can say. It's a general topic which can be taught even to a common man who can calculate all the problems in this one without the knowledge of any engineering subject. Like further, this is such a topic which will come throughout your career, like even if you go for any competitive examinations also, it will come. So before entering into the topic permutations and combinations, and let me first explain you what is the principle of counting. You can see that slide there, and the principle of counting, you can see this is if an operation can be performed in A different ways independently, second operation can be performed in B different ways independently, and third operation can be performed in C different ways independently, and so on and so on. Then all these operations, one after the other or simultaneously, can be performed in A into B into C into and so on different ways. That is the definition of principle of counting. So similarly, if you see the second part of that slide there, similarly either of these operations can be performed in A plus B plus C plus and so on different ways. So what does it mean? What is the meaning of an operation? You know, the operation, for the purpose of definition, it is named as operation. Operation is nothing but the day-to-day works which we take up is termed as operation here. So let us see an example to better understand the definition here. So let us see the example now. That if you see here in the next slide, the principle of counting, yes, example 1, that is, if there are 18 railway stations on a railway line, then how many second class railway tickets are to be printed that enables a passenger to travel from one station to another? Please go through the question carefully. If there are 18 railway stations on a railway line, then how many second class tickets are to be printed that enables a passenger to travel from one station to another? If you go through the problem carefully, the general thinking you must have is this. If you go to the railway station and if you take a railway ticket, for example, you are traveling from Hyderabad to Nagpur, let me say. So then you'll go to the railway station and you'll ask for a ticket in the counter. Then a ticket will be given, and on that ticket you will have the two stations printed like this. It is Hyderabad to Nagpur. Hyderabad to Nagpur, let me say NGP, HYD stands for Hyderabad. Now the railway people, for example, you have become or you have become a railway official, and you have to count how many number of tickets are to be printed for the passenger to travel on all these 18 railway stations. Then you must have the basic knowledge of this principle of counting. Then when you take this ticket, on the ticket you can see that there are two stations printed here, and in the problem given, how many stations do you have there? You have totally 18 stations. Among 18 stations, Hyderabad and Nagpur also, two stations are in, these two stations are included in the 18 stations. So, in the first place, how many stations can be printed? In the first place, how many stations can be printed? That is, from Hyderabad to Nagpur, the ticket is given. Then, in the first place, you can print any one of these 18 stations given. Any one of these 18 stations given. For example, from Hyderabad, you will reach to some Karimnagar, or we will reach to Warangal, then Karimnagar, then Balarsha, then Nagpur. Like that, all those stations can be printed here. So, in how many ways the first operation of printing the first station can be done? Printing the first station can be done in how many different ways? It can be done in 18 different ways. Understand it? 18 different ways. So, if one station is already printed, then how many stations are remaining that are to be printed in the second box? Because one station is already occupying the first place, the remaining stations are to be printed in the second place. How many are they? Remaining are 17. Then you may think, sir, why not it is 18? Alright, you can understand that you never take a ticket from Hyderabad to Hyderabad. That is why when you take any ticket, the two stations will be different and it will not be same. So when one station is occupying already one place, that station is to be eliminated in the second place. So here, in the principle of counting, the first operation of printing the station in the first place can be performed in 18 different ways. 18 different ways. And the second operation can be done in 17 different ways. So, these two operations, one after the other or simultaneously, can be performed in 18 into 17 different ways. You can count it, of course. 8 sevens. 6, 1, plus 2. So, the number of second class railway tickets that are to be printed are 18 into 17, that is 306 number of tickets are to be printed in this case. So, performing the first operation can be done in 18 ways, second operation can be done in 17 different ways. These two operations, one after the other or simultaneously, can be performed in 18 into 17 different ways. Okay. Similarly, if you go to the second example, Mr. Rahul has 5 different colored trousers, 7 different colored shirts and 3 different colored blazers to wear. How many, number 1, different colored triads he can wear in the same order? So, what does it mean? You can see the problem carefully. Please go to the problem once carefully. That is, number of trousers or 5. Trousers are nothing but pants, I can say. And number of shirts or 7. And number of blazers or 3. Now, number of how many different colored triads he can wear in the same order. In the same order means first a trouser, then shirt, again on that one blazer. That is the order. This is triad. I termed it as triad. So, in how many ways it can be done? And you can see how many trousers are there. Let me say trouser for the better understanding. T1, T2, and it is T3, T4, T5, and shirts S1, S2, S3, S4, S5, S6 and S7. These are the shirts. And blazers B1, B2 and B3. Now let us start from the first trouser and first shirt. So he's wearing the first trouser on that one. First shirt he's wearing. Then for this combination, how many blazers he can wear? Number 1, number 2 and number 3. So for the first trouser and first shirt, he has 3 blazers to wear. That means it can be performed in 1 into 1 into 3 different ways. Similarly, for the same trouser, he can shift to the second shirt, and for the second shirt also, again he has 3 ways to go with the blazers. So again, it is also 1 into, this is 1 into, again 3 ways. So 1 into 3. So how many will get like that? So for this trouser 1, that is first pant, he has 7 shirts. Again, for each shirt he has 3 blazers. So he will get 7 such type of different combinations in this case. 1 into 1 into 3 plus 1 into 1 into 3 plus so on. How many times? 7 times he will get. So it will be nothing but for first pant. This is for first pant. He has how many? 1 into 1 into 3, 1 into 1 into 3, 1 into 1 into 3, so on 7 times. So it is 1 into 7 into 3. These are added 7 times. So for the first pant, he has 7 into 3 combinations. You can understand. For the first pant, he has 7 into 3 combinations. And for the second also, same. For the third also, same. For the fourth also, same. For the fifth also, same. So it will be added how many times? 1 into 7 into 3 plus 1 into 7 into 3 plus and so on. How many times? 5 times. So it should be like 5 into 7 into 3. Understand it? So the first operation is nothing but the wearing the trouser here, and second operation wearing the shirt, and third operation wearing the blazer on it. So and all these can be simultaneously done in how many different ways? 5 into 7 into 3, which is nothing but this is 35 into 3, which is nothing but 105. That means with these 5 trousers, 7 shirts, 3 blazers, he can create 105 different combinations. 105 different combinations. So this is a better example to understand the principle of counting. The first operation can be performed in 5 different ways. Second operation can be performed in 7 different ways. Wearing the blazer can be performed in 3 different ways. So all these can be simultaneously done in 5 into 7 into 3, which is nothing but 105 different ways. Now coming to the next question, please go through that. How many ways he can wear either trouser or shirt or blazer? Either trouser or shirt or blazer. This is and trouser and shirt and blazer. But the second case, if you see that, it is either trouser or shirt or blazer. Okay, so now the first operation of wearing the trouser can be done in how many different ways? It can be done, you can see, in 5 different ways. It is 5 only. Either this or this, that is, or shirt can be done in 7 different ways, and blazer can be wear in how many different ways? 3 different ways. So either this or that or this can be done in 5 plus 7 plus 3 different ways, which is nothing but 15. Find the difference here. Very basic thing where the students generally used to ask the questions like this. Why should we add and why should we multiply? Understand it clearly. and in the previous case we have multiplied. In this case we have added. The reason you understand it, come to the previous slide please. Please note that, please note, if you go through the please note, and stands for multiplication or intersection. Further, after the introduction of set theory, understand it, wherever you get and, instead of and, you have to write into multiplication, and instead of into you will have to use intersection, or intersection can be written as into multiplication and into can be written as the and. So there is no difference between these three in permutations and combinations. Understand, whenever you come across and in the problems, multiply or use intersection. Whenever you get intersection, use into, that is multiplication. Similarly, if you have R here, if you see that R stands for addition. Addition means, you know, plus, and that plus after the introduction of set theory, and you know that you will be learning the probability based on these permutations and combinations. In the probability, this union will be converted as addition, plus this plus is nothing but R. So no confusion while solving the problems where to use multiplication and where to use addition, simply based on this. So and into intersection, R plus union. This is a very important point to be noted while working out the problems. Okay, so now today what we do to get more confidence in working out the problems, first of all, we will learn the basic problems that can be solved only on the basis of principle of counting. So how do you analyze the problem? Mainly in solving the problems of permutations and combination, and further in probability also, the approach in solving the problem is very, very important. So here also, whenever a problem is given, your approach in solving the problem should always be like this. You will feel the problem easy when you separate the operations. And separate the operations means what we did in the previous examples, we have separated the operations. What are the operations there? In case of tickets, what we did, we applied our general knowledge. What is the general knowledge? General thinking. Everybody knows that when you go to a railway station, you will take a ticket. On the ticket, you must know, you all know that you will find only 2 stations on the ticket printed. So how do you proceed? We have considered the 2 places there, 2 blank places. That is the approach. That's very important. So in these blank places, then we will think. How do we think? How this blank place can be filled? How many stations are given in the previous example? 18 stations are given. That is why we filled it 18, and the remaining in 17. Then why not 18? Then it is also common sense. What is a common sense? We never take a ticket from Hyderabad to Hyderabad, or Nagpur to Nagpur, or Delhi to Delhi. We never take. That is why it should not be repeated. So that station which is filled already in the first blank place should be eliminated here. First operation, second operation. We have split the operations like that. Similarly, in case of the trousers, shirts and blazers also, we have separated the operations. So whenever you solve any problem that is when you are solving any problem related to permutations and combinations, or further in probability also, first of all separate the operations and then proceed to principle of counting, or whatever the permutation or combination further we are learning, you apply them. Okay, now let us see some basic simple problems based on this principle of counting. Okay, now the first question here, you can see, find the total number of 8-digit numbers that can be formed. Very simple question. Nothing is given. A single sentence, you can say, find the total number of 8-digit numbers that can be formed. Then what must be your thinking? 8-digit number means it will contain always 8 blank places. 8 places will always be there. 1, 2, 3, 4, 5, 6, 7, 8. Now in these places, the digits will be present. You know that. It is ones place, tens place, hundreds place, thousands place, 10,000 place, and so on like that. Okay, and digits will be present in this one. Now what the question is here, you need the total number of 8-digit numbers that can be formed. So what are the digits we have in our hand? Nothing is mentioned in the question. So you have to take all the digits that we know. What are the digits we know? It is 0 to 9. How many are there from 0 to 9? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 digits are there in our hand now. Now these 10 digits only to be used to fill these places. It's common sense. You can understand that. So in that case, the common thinking must be like this. This blank place can be filled in 10 different ways if I say. Then immediately you must object. Why? Sir, in the question it is given that we need an 8-digit number in these 10 digits. If I fill 0, then it will not be 8-digit number, but it will become a 7-digit number. Absolutely right. So your thinking must start there. So 0 should not be filled here, because if you fill 0, what happens? That will become a 7-digit number. So 10 digits should not be filled. Then in such a case, 0 should be avoided. So I will fill it only in 9 different ways. 9 different ways. By avoiding 0. I'll avoid 0 here. That is why I put an into mark here for a better understanding that 0 is avoided in this case. Now, coming to the second place, there is no objection at all. You can write 0 here. So how many digits are there in your hand? There are 10 digits. Here also 10 digits. Here also 10 digits. Here also 10. Here also 10. Here also 10. Here also 10. Then you will be thinking in this way. You may be thinking in this way also. Like, sir, when one digit is already occupied, why are you using that digit here? Nothing is mentioned in the question, I say. Nothing is mentioned. If you are asked to find out a 8-digit number that contains different digits, then you have to fill like that. But nothing is mentioned here. We need 8-digit numbers. So that is why repetition is also allowed. That's what I mean to say here. And if the same question is, I'll alter that question and I'll discuss with you now. But before that, let us finish up this first. So because 0 is not allowed in the first blank place, if you fill 0 here, it will become a 7-digit number, but not an 8-digit number. That is why that is avoided, and only 9 chances are there. The first operation can be performed in only 9 different ways. Second, 10 different ways. Third, 10 different ways. Fourth, also 10 different ways. All these operations, one after the other, or simultaneously. All these operations, one after the other, or simultaneously, can be performed in how many different ways? 9 into 10 into 10 into 10 into 10 into 10 into 10. So, the number of 8-digit numbers that can be formed or that are present is nothing but 9 into 10 power 7. These many 8-digit numbers will be there. So you can see the answer also, that is 9 into 10 to the power 7. So that is the answer. So let us not limit ourselves to this one only. Now let us discuss. Among all these 8-digit numbers, how many are even numbers and how many are odd numbers? How many are even numbers and how many are odd numbers? Let us see that. then you are the better judge to decide that how many even numbers will be there, how many odd numbers will be there. If I write 0 to 9 digits, 0 to 9 digits, then among this, how many are even, how many are odd? You know that this is even, that is 5 digits are even and 5 digits are odd. That means all these digits, you can understand, they're equal in number, 5 even, 5 odd. Then what I'll do like this. What I need now, number of even numbers above, number of even numbers above. We need that. So what I'm doing, first I'll fit 0 here. I'm avoiding this because my even number or odd number depends on this place. If this place contains a number which is divisible by 2, then you can say that it is an even number. So I can fill this place either with 0 or with 2 or with 4 or with 6 or with 8. Understand it please carefully. Then what happens? If you need the number of even numbers in this case, then this blank place should be filled only with any one of these 5, but not 10. If you fill it with 10, then what happens? The total number of 8-digit numbers you will get, but I need only number of even numbers. That is why I am filling it with only 5 different ways. The number of even numbers will be, then in this case will be, what happens? It is 9 into 5, 45. How many tens are remaining now? 1, 2, 3, 4, 5, 6 tens are remaining. So 45 into 10 power 6. Understand? So the number of even numbers in this case are 45 into 10 power 6. Similarly, number of odd numbers also same. It will be equal. Understand that. It will be equal. If you add 45 into 10 power 6 and again 45 into 10 power 6, you will be getting this. So half of them are even, half of them are odd. Just I want to tell you how that principle of counting can be used in this case. You understand it. So that changes according to the need. Here you need an even number, that is why it is filled with 5 ways, and if you need an odd number also, it should be filled with 5 ways. And you will be getting some questions like this: what should be the how many numbers will be there, whose sum is even, the digits that are present in these places, if you add the digits, the sum should be even and the sum should be odd. Then in that case also the same answer. Think of it. How is it? Think of it. You can understand easily based on this. Okay, so coming to the next question. Find the number of quadratic expressions that can be formed with the coefficients from the set 0, 1, 2, 3. How many of these touch x-axis if shown on the graph? So this is a very simple question, you can understand. But before that, what the algebraic knowledge you must have. What is the question there? Find the number of quadratic expressions. So when you come to quadratic expressions, if I ask you the question, what is the standard form to the quadratic expression? You can think, you can say, everybody says that it is ax square plus bx plus c. Everybody says that, but very, very few say that where a not equal to 0. It's a previous question, I say, and these are small things we generally neglect, where the questions will be formed based on such type of small things. So ax squared plus bx plus c, understand whenever the question is asked what is the standard form to the quadratic expression, the leading coefficient should not be 0. So the standard form to the quadratic expression is ax squared plus bx plus c. And so what is a set now given? The set given now is 0, 1, 2, 3. So how many digits do you have here? 4 digits you have. And how many places you have here? Those numbers are to be given to ABC. That means in place of A, you have to write either 0 or 1 or 2 or 3. That means what? Here, as I already told you that A is not equal to 0, it should be filled only in 3 different ways. Understand? Which is very important thing. And B can be filled with any one of these 4 digits. So it can be filled in 4 different ways, and C can also be filled in 4 different ways. So the first operation we have performed in 3 different ways, second operation we performed in 4 different ways, third operation we performed in 4 different ways. All these operations, one after the other or simultaneously, can be performed in 3 into 4 different ways, which is nothing but 48. So what you understand here, 48 different quadratic expressions can be formed using the digits 0, 1, 2, 3. So how they will be? Let us suppose A1, 1 into x square, B also 1, let me say x, C also 1, let me say 1. That means in this case what I did, in this case what we did, A is equal to B is equal to C is equal to 1. I have taken an example. So it is a quadratic expression. Understand? Similarly, A1, B2, that is 2x, C1. In this case, what I did, A1, B2, C1. Now, if you see this carefully, the question given there is how many of these touch x-axis if shown on the graph. So, you all know the graph of a quadratic expression. It is from the lower classes itself, from your 10th class itself. You have learned the standard form of this quadratic expression. If you take it as fx, or if you take it as y is equal to fx is equal to x squared plus x plus 1. And if you show this on the graph, if you put x equal to 0, then it is 1. X equal to 0, it is 1 somewhere, it will cut here. And if you see the discriminant, you know the discriminant for this one, all of you know, b square minus 4ac is nothing but 1 minus 4 is less than 0. Its discriminant is negative. That means it doesn't have any real roots. Doesn't have any real roots means it never cuts x-axis. Why shouldn't it cut x-axis? Because if it has any real roots, it will cut x-axis. If not, it will not cut x-axis. That is why it will be something like that. So, which is not our required expression. So, let us come to the second case now. This is x squared plus 2x plus 1. Then, x plus 1 whole square. This is, you can understand that it is nothing but x plus 1 whole square. If you see the discriminant of it, what is the discriminant? B square 4 minus 4 into 1 into 1, 0. 4 minus 4, 0. That means it will have roots but equal roots. So what are the, where does it touch x-axis? So if you see this carefully, when the discriminant becomes 0, if the roots are equal, what are the roots in this case now? Minus 1,